Alright, okay, we have this one, and then we have this one. So, normal Sudoku rules apply, again. 1 to 9 in every row, every column, and every 3x3 box. Normal zipper rules, so lavender lines. Digits an equal distance from the line must sum to a digit in the middle of the line, so a cell here, that is the center. Digits in equal distance away, so say 2 cells away. These must sum to the cell in the middle. These are 3 away, so they must sum to the middle, and these must sum to the middle. Same here, these must sum to this value over here. Next, anti-knight. Cell separated by a knight's move in chess cannot contain the same digit. So this cell, whatever that is, it sees all these cells normally by regular Sudoku. But not only does it see those cells, it also sees this cell, because if you were a knight here, you could jump to here. You could also jump to here, 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 and here. So those are all not allowed as well. And the final rule set, killer cage rule. So digits in a cage must sum to the number in the top left corner. These 3 must sum to the number here. So these 3 sum to 10. These 3 sum to 24. These 3 sum to 8, and so on and so forth. Those are the rules. Let us begin solving. The things that immediately catches my eye is that these are both 24 cages, and maximally you could put 7, 8, 9 on those cages. And those sum to barely 24, which means that these must just be as high as you can get, 7, 8, and 9. This 8 here must have a 1 in it, because if you didn't have a 1, let's say you had a 2, 3, and 4 minimally, then that would sum to 9 at least. So this cannot have no 1 in it, and so must have a 1. Oh, that's interesting. Both of these actually see this cell, which must be quite large, because these 2 cells sum to this. So these 2 cells sum to this one, these 2 cells sum to this one, and these 2 cells sum to this. But this can't be 7, 8, or 9. That does look... it's very constrained, definitely, but... does it even work? How would that work? How would that work? Okay, say this was a 6. Then these 2 cells sum to 6. Oh, they can repeat. I realize that now. They can repeat. So they could be both 3s. Because that doesn't break any Sudoku rules, and nothing says that a line cannot repeat digits. So they can repeat. Very cool. Then what? Can this be as low as a 5? Well, I mean, obviously it can't be as low as a 2, because a 2 here requires you to put 1 and 1 on both sides, and then you'd have to do the same for all pairs, which really fails because you have like so many 1s in the row. So it can't be a 2, it can't be a 3 either, because a 3 has to be a 1 and a 2, but it has to be a 1 and 2 3 times, which then puts 3 1s and 2s in the box, which fails, obviously. And similarly, it can't be a 4, because a 4... well, a 4 could work, because this could be a 2 and a 2, this could be like a 1 3, this could then be a 1 3. So this could be a 4. Wow, that is really challenging. So this could be anywhere from 4 to 6. Ah, I think I see it now. Yes, okay. The trick is to notice that these cells sum to 45, because they have to be all digits 1 to 9. And you sum that up, you get 45. We've said this before early in the stream. We also know how much these sum to. And the trick is that, well, because this is 24, this must be the remainder. That is 45 minus 10 minus 24 is 45 minus 34. So this is 11. Wait. No. This is 20 what? No, okay, 10, 24 gives us 34. And 45 minus 34 gives us 11. Oh, something's up. Wait, no. I'm thinking about this wrong. Sorry, this doesn't sum to this, does it? No, it doesn't have to. No. This and this sum to that. This and this sum to that. And this sum to that. So this plus this is 3 times of this. Yes, okay. So this and this sum to 3 times of that. I want to put that down somewhere, but I can't do that. If this is 11, then this... How can you make these sum to 3 times of this? Well, let's figure out what 3 times of each mean. 3 times of 4... 3 times of 4 fails, because 3 times of 4 is 12, and you already have 11 here. You'd have to have like a third in each cell. That's not even a thing you can do. So this clearly can't be a 4. Can it be a 5? A 5... No, because a 5 would make these sum to 3 times of that. That's 15. But we know this is 11, so this sums to 4. But you can't do that because at minimum, this has to be... At minimum, this has to be 6, because 1, 2, and 3 makes 6. So this can't be a 4, meaning that this can't be a 5, otherwise you'd have this sum to 4, which is impossible. So this can't be a 5, and therefore it's just a 6, giving us our first digit. Alright, so what do these sum to then? These sum to 6 times 3, that's 18. This sums to 11, so this is 18 minus 11, which is 7. And 7 in 3 cells can be only made in one way. 1, 2, and 4. And then these sum to, well, whatever this is, 6 is, this cell, my goodness, is 6 minus that. So 6 minus 1 is 5, 6 minus 4 is 2, 6 minus 2 is 4. So all of these are 2, 4, or 5. Okay, those are my numbers, wow, okay. And then the remaining cells here are 1, 3, and 6, which do in fact sum to 10. These numbers are 3, 5, and 6. It doesn't matter what they sum to. But there we go. I feel like all these pairs look into this box very glaringly. Although I can't say for sure exactly how. Oh, anti-night. I really forgot about the anti-night rule. Yeah, some of these actually see a lot of things. Like this cell sees all of these, but also sees these 2 cells. And then same here, this actually sees all of these. What about like this one? This one sees that as well, but it can be anything else. Okay, I don't know if anti-night helps us here. Anti-night. Okay, well at least we have some clue of what we have. This 2 and 4 means there's no 2 and 4 here. This 1, 2, 4 means there's no 2 and 4 here. So these must have a 2 and 4 somehow. Not like this, like that. Can this be a 2? No, I can't, because these would have to all be 1s each, which already fails. So this can't be a 2. Can this be a 4? No, because 4 is only... Yes, because now these can be 1. So this has to minimally be 2, 3, 4, because we know there's already a 1 in the 8 cage. So this is minimally 2, 3, 4. This would then make this at least a 9. So this and this, we've used the trick here. This and this sums to 3 times of that. What does that mean? Then, yeah, if this is at least a 9, then this is at most a 3, I think. But we can't do that because this is already at least a 6. So you can't have anything less than 3 in here. So there can't be 2 or 4, meaning that 2 and 4 exist outside here. Hi. Follow for follow? What? Who are you? Wait, can I see? Bro, you don't do anything. Okay, I'm not going to follow you, I guess. You just came into my stream and asked me to follow you? Okay. Anyway, that was so dumb. What? Okay, 2 and 4. You broke my train of thought. I mean, can we do similar things with 5 and 3s? Because, yeah, 1 is in one of these 2 cells because of all these 1s. And then the 5s here, see those? So these are 5s. 5s in one of these cells. And then, well, we can do the same thing for 3 and 6. Oh, we can't do the same thing for 6. I realize that 6 here sees those cells, but we already have 6 in the box anyway, so the logic does not hold there. Okay, I do want to go back to Twitch and see what's going on though. Anyway. So 3 is in one of these cells. Does that help? Yes, because this can't be a 1. Because a 1 here would remove 1 from here by knight's move and a 1 from here by knight's move, giving us 0 positions to place a 1. So this can't be a 1. This can't be a 5 by similar logic. 2 and 4, another 2, 4. I mean that works because 2 and 4 add to 6. No knight's move constraint here though. And they have to be different. Because they can't be both 2 or both 4. We didn't know these are the other set. Okay, well. Honestly, we look at this next. Maybe. Maybe. Oh, this 8 cell. This 8 over here means that if there's a 1 in there, the others must sum to a 7. So you either have 1, 2, 5 or 1, 3, 4, I'm pretty sure. 1, 2, 5 or 1, 3, 4. Doesn't that restrain this? If this... Yes, because if this are 6 different digits, they sum to at least 21, which is 1, 2, 3, 4, 5, 6 added together. So these 6 digits sum to at least 21. Therefore, these digits are 21 minus 8, which is 13. So these digits are at least 13. Does that help? These digits sum to 3 times of that. No, I don't think so. Because, I mean, it sort of does. Because if this is 13... Oh, yes, yes. Wow, okay, that is actually a lot more constraining. 13 plus 6. Oh, I'm just kidding. It's not constraining at all. 13 plus 6 minimally. Well, it's actually 13 plus 7 because you have 3 here. But minimally, this is 13 plus 6, which is 19. So this is at least 19. Oh, hi, Lugia. Welcome back. Welcome back. How was the puzzle? I hope it was doable. I'll see if I can find the solution for you. I solved it just now. Are you okay? I'm gonna continue doing this though. This is at least 19 because 13 at least here, and this is at least 6, so this is at least 19. This is 3 times, oh, these are 3 times of that. So this is, this can't be a 6 because 6 times 3 is only 18. So this is at least a 7. So that works. Welcome. Oh, congrats. It's a pretty decent puzzle to solve actually. I think it was fine. I think it was an okay puzzle. It's a very nice thing to do, like, you know, while you're in bed. But I'm doing this one. It's lagging a lot. Oh no. Oh no, it's lagging a lot. Okay. I'm sorry. I don't think I can do anything about it. I can see if I. I think this is okay for me. Yep. Okay, it's fine for me. I'm sorry. I'm sorry if this is bad for you though. Okay, what was I doing? Right, teaching you the rules of this one. This one's a bit special. Yeah, this one's a bit special because there are 2 new rules here besides the normal killer cages. These are zipper lines, which means that, like, it's kind of like spreading out. These 2 must sum to the middle cell, these 2 must sum to the middle cell, and these 2 must sum to the middle cell. So like it spreads outwards, which must each pair sum to the middle cell, basically. Yeah. And then also NT-knight, which means that any cell here, if it's a knight moves away in chess, I hope you know what chess is. I'm sorry that was insulting, I'm sorry. Basically, if it's a chess moves away, then these 2 digits can't be the same. These 2 digits can't be the same. And so on and so forth. Yeah. Well, I'm glad you know what chess is. I'm having a bit of trouble with this though. I'm not sure where exactly to move on to. Okay, let's see. Do these have to be different? They can be both, like, they can be both 2, right? Yeah, they can be both 2. So that means that this could be like a 4, because even though these are both no longer 4, they could be both 2 as well. I think that's fine. Yeah, okay. And then I guess something similar goes on here, that this could be a 2 or a 4 as well. But, okay, what if these are different then? What if they were different? What if these are different? If this were 2 and 4 differently, then this would have to be none of it. This would be neither. This would be 5. This would have to be 1. And you have another 2, 4 there. I mean, I guess that's not impossible either, I don't think. Oh, that's weird. like 4, 2, 2, 4. These are not a knight's move away, so they don't have to be the same. Okay. I mean, okay, let's see. What is this? Is this a 3 or a 5? Oh, this. Oh, I mean, okay. I should have really seen this, but these can't be 6s. I'm not sure how much that helps. But by knight's move, these can't be 6s. This one can't. Yeah, this is a 6, 7, 8, 9 here. So these are 1, 2, 3, 4, and 5. This can't be 1, 2, or 4, so they're just 3 and 5. Which is interesting, I guess. But I think it forms a very similar pattern with these cells. Can I do the same here? Yeah, because these have to be 1, 2, 3, 4, and 5. But these are 2, 4, and 5, so this has to be a 1 or 3. Which forms a very similar pattern again. Yeah, what am I not seeing? If these two are the same, then it would have to land up here. If these two were different though, then these two are the same, which have to land up here. But that's fine, isn't it? And like, that imposes 0 restriction. Yeah, I'm a little bit confused here. I'm pretty sure it's something to do with the knight's move that I'm not seeing somehow. Maybe it's like the knight's move here. If this was a 2 or a 4, then this is a different value, and this is a different value. And then this, so okay, if this is a 2 or a 4, where's my numbers? What? Where are my numbers? Uh-oh, and I will pen 2 and letter 2. Alright, if, oh wow, oh I can't even undo, oh my goodness. Okay, Jesus Christ. If this was a 2 or a 4, then this and these are different, meaning that whatever this is not that, and then this is also the different one. It's the other one from 2 and 4. This is the other one, and because these two must be different, this is the other one. Does that impose any restriction at all? No. Wow, this could be anything, and this could also be anything. Jeez. Okay, what if these were different? Then this is that. this is that. This can't be here, so that will be that, and then this can't be here, so that will be here. Why is that? Why is that not? Oh, why is that an issue? No reason. Okay. Clearly not seeing anything else here. 5, 2, 5, 2, 5. I mean, maybe it's something to do with this. Like, if this was a 5 somehow, and this is a 3, this is a 1. Not entirely sure what that does either. Maybe it's still this 7, 8, 9 that I'm looking at. Although it's a lot less about a lot less about, you know, what if it was a 7? This is at least a 13, this is at least a 7, this is at least a 20. I feel like the 136 helps somehow here. Because this is either a This is either a 134 or a 125. Oh, does 125 not work? Yeah, what if this was 125? If this was 125, then these cells are heavily restricted by this triple and this triple, because there cannot be a 1, 2, 3, 5, or 6 on it. So the remaining cells possible are 4, 7, 8, and 9. Yes, yeah. Wait, okay, no, we're trying to disprove this. This is not true yet. But because 9 cannot appear on this side. Yes, 9 cannot appear here. And the reason why is because if 9 did appear here, then this must therefore... if 9 was here, then there must be at least some number here that matches the 9. And that would sum up to 10. So this has to be at least a 10, which doesn't work. So there can't be a 9 here. And so, because there must exist an 8 here, the opposite side must have a 1, which would then put a 9 there. So in this case, there will be a 9 there. And that fails, because wherever the 4 is, must have a 5 on the other side. But we already know there's a 5 in one of these cells. Oh, okay. So, the 4 here will put a 5 here, which then fails this set. So we know this does not work, meaning that our initial assumption of 125 fails. So this is a 134. Wow, that is something. So this is now a 2. That is a 5. Jeez, that's a 4. That really is something, isn't it? This can't be a 4. This can't be a 2. This can't be a 5. This, we still don't know. Not done yet. Not done yet. What is minimally the things I can put here? Isn't it 257? Because I can't have a I can't have a 1. I can't have a 3, I can't have a 4, I can't have a 6. So it has to be 257 at minimum. And 257 adds to 14. 14 here with a minimum of 7 here is 21. No, can't have a 2. Can't have a 2 or a 3. So 14 here is minimum. Minimum here is 14. Here, minimum is a 1, 4, and... oh, 1, 4, and 7! Because it can't have a 2, it can't have a 3, it can't have a 5, and it can't have a 6. So minimally, this is a 1, 4, 7, which adds up to 12. So minimally this is a 12 and minimally this is a 14. That adds up to 26. So at minimum this is a 26, which means that this has to be at least 3 times, or 26. Okay, sorry, what am I saying? 3 times of this has to be at least 26. And that only works if this were a 9. If it was an 8, you'd have 24, which is less than 26. And if it's a 7, it's 21, which is even less. So this has to be a 9, because it has to be at least 26 when you multiply by 3. Okay, wow. And this is barely bigger though. This is 27, right? Yeah. Yes, yeah. Okay, this works. And the good thing is, where does 8 go in this row? 8 can't be here, because wherever you put 8 here, the other side here must have a 1 to add up to 9, but that fails because there's already a 1 in one of these cells. So 8 can't go in anywhere there, so that is an 8. That is a 1. Cool. These cells are 3 and 7. This means there's a 3 here and there's a 7 there. These cells are 2, 5, 8. 2, 5, 8. These cells are 1, 4, 7. Which works, yes, because 7 would match 2 here, 4 would match 5 here, 1 would match 8. Okay, this 3 removes a 3 from that. This 2 removes a 2 from that. This 8 removes an 8 from that. This 7 removes a 7 from this. 4 removes a 4 from that. This works now because 7 puts a 2 here, which we know there isn't. 8 puts a 5 puts a 4 here, which we know there isn't. So it's only possible for this to be a 1, 8 pair. So that has to be like that. This is now a 4, making that a 5. This is now a 7, making that a 2. Oh my goodness, that was really something. This must now be 6, 7, 9. 7 sees that. 9 sees that. Nothing to disambiguate that yet. Okay. So far we have that. What else do we have? Maybe this line now? No, not those cells, those cells. Like, this can't be a 7 or 8, can it? Because the 8 here sees that, the 7 here sees that. So this is less than that. It could be a 9 as well. Can it be as low as a 6? Yeah, it can. Because... well, how do you make this a 6? These would be 2 different pairs, right? And you can't repeat because it's all in the same box. So a 6 here requires a 1, 5 and a 2, 4 somewhere. But I think it doesn't work. Because a 1 sees these cells and that cell by knight's move. And a 1 can't go here, otherwise a 5 goes there, which fails that. So this 6 here means that 1 cannot appear there. So this can't be 6. Can it be 5? We know it can't be 4 or 3 or any lower, because 4s and 3s only have 1 pair possible. So you can't have 2 distinct pairs add up to 4. So this one, let's check if this can be a 5. A 1 doesn't work. We know 1 cannot be here, and a 1 can't be here either, because that would put a 4 here, which sees that by knight's move. So this can't be a 5, meaning that it can't be a 5, 6, it can't be 7, 8, and therefore must be a 9. Oh my. Yep, it has to be a 9. That sees that, that's a 6, that is a 7, that is a 9. Cool. this 3 sees that, so that's a 5. Didn't see that one. This 3 sees that, so that is a 1. So these two add to 9, these two add to 9 as well. We don't have much to do on that though. Oh, right. Well, where does 9 go in this box? This 9 and this 9 see those cells. And 9 must appear somewhere on this line therefore. But 9 can't appear on the ends, because the other side plus the 9 adds to the middle digit, which would then have to be bigger than 9. So these can't have 9 on them, and this must therefore be the 9. That can't be a 9. So these sum to 9. I don't think that helps. I think we need to look at something else. Like that, maybe? Yeah, we can sort of look at that. I think. It might be beneficial to look at that, in fact, yeah. Okay, so this cell. That sees this cell. It sees that cell. It sees that cell. By Sudoku and Knight's Move. It sees all these cells by Sudoku. It sees that by Knight's Move. It also sees that. Although this isn't very helpful. In fact, this doesn't help at all. What does help is that it can't be a 1, 2, or 4. It can't be 6, 8, or 9. So it can be a 3, a 7, or a 5. Okay, that helped a lot less than I thought it would. Yeah, it really did not do much. Okay, well, whatever that is. Oh, it's this one. Yeah, how do you make 9? You have... Your choices are 1, 8, which is fine. Your choices are also 2, 7, but this 7 makes it not possible. 4, 5, which isn't possible because of that 5, and 3, 6, which at first looks possible, but then you realize that this cell over here, sees both of these cells by Knight's Move. So that means that these can't be 3, 6, because they would remove both candidates from this cell. So this can't be a 3, 6 either, meaning it has to be a 1, 8. And that removes a 1 from this cell. What else does it do? I mean, it removes 8 from here, and this 8 removes that. I guess 8 can't be here either, because an 8 here puts a 1 there, which sees that by Knight's Move. I mean, an 8 sees that by Knight's Move as well, so 8 is in one of those cells. Seven sees these cells and that cell. What have we figured out? That there cannot be a 1-8 pair making the 9. I was wondering, can a 7-2 pair make the 9 then? But this 7 sees these two cells, this 7 sees that cell. So 7 cannot go in here. And conversely, 2s cannot go in here. But that's very unfortunate, because that means 2 can go here if 7 goes there, which isn't restrained by any type of Knight's Move. So that's pretty unfortunate. Yeah, that is pretty unfortunate. So what else can we remove? Can we remove a 5? 5 can't be here or there. 4 can't be here or there, but 5 and 4 can definitely reside on the outsides. And that's possible. And then 3, 6. Well, 6 can't be anywhere here, so 3 can't be anywhere here, but this could be anywhere. Yeah, so 6 can't be any of these or that, but this could be a 6 if this was a 3. So 3, 6 can in fact lie here as well. Oh, wait. This must be a 3... No, it doesn't. Wait. Does it? 4 can't be... 4 sees these cells. 5 sees these cells. Yeah, okay, wait. We can do this one, This can't be a 1-8, because 8 already exists somewhere else. This can't be a 4-5, because 4 sees both of these cells. And it can't be a 3-6, because 6 sees both of these cells. So it must therefore be a 2-7. This 7 sees that, so that's a 2. That's a 2. That's a 7. It's no longer a 7. And then these ones... Well, they're either a 4-5 or a 3-6. This 6 sees that, so that can't be a 6, meaning this can't be a 3. And that is... What was that? That is something else we have. Not much else though. Not much else. I mean, we guys could figure out what these are. Yeah, definitely. Maybe that helps. These are 8. 6, 8, 9. Ah, and this 9 sees both of these cells. Okay, so this is just a 9. These are... Oh, well, 8 sees that, so that's a 6. That's an 8. Meaning that's no longer a 6. And this is therefore no longer a 3. Cool. These are... 2, 3, 5. 2 and 3. This 2 sees that. This 3 sees that. So that's a 5. I don't see much else though. This 5 sees that. So that's a 4. That's a 5. This is not a 4. Okay, we're knocking this out very slowly, but I think we're making progress. I think. Are we? Sure, what are these cells? 3, 7, 8. Okay, what can we remove from that? 7 here sees that, 8 sees that, so this must be a 3. 3 sees that, so that must be a 6, that must be a 3. Okay, fix that section. This 5 sees that, so that's a 3. This can't be a 3, so that's a 6, that is a 3. Here we have 1, 2, 4. This 1, 8 pair removes a 1 from that. So this is a 1. That's a 3, that's a 4. 4. Okay. Anything else? No? This one, yes. This cell sees both of these. So a 4 here would remove 4 from these cells, which isn't possible. So this is a 1. And you have like a 2, 4 here. This 1 means that's a 5, so they add to 6. And I guess the only way these are ambiguated is by this cell here, which must add to that. Add with that to make a 6. But yeah, it's resolvable, so no issues. Where does 3 go in this box? These 3 see those cells. These 3 see those cells, so that is a 3. 3 here sees that cell, so that can't be a 3. That's a 3. And this box, where does 3 go? 3 and 3 see those cells, so the 3 goes there. In this row, what's the final number? A 6. So that's a 6. What are these? These are 1 and 8. This 8 sees that, so this is a 1. That is an 8. Can I like place a 7 here? Does it mark me wrong? It does, by Knight's move. Okay, very good. That means nothing is wrong so far. I haven't missed anything yet. What are these cells? 2, 5, 9. This 2 and this 5 see that, so that's a 9. Okay. What are these cells? These are 1, 4, 6. 1 sees that, 6 sees that. Oh wow, really? Not much else, huh? Alright. What else can we do here? I mean, okay, what's here then? 5, 6, 7. 5 sees that, 6 sees that, 7 sees that by knight's move, so that's a 6. What else by knight's move can I do? Nothing else. Wow. What a horrible... Okay, whatever. Oh, what am I supposed to do here? Oh my goodness. Yeah, how does this resolve? We're basically done with everything we've had so far. So it's just Sudoku now. What about this cell? Yes, there are 2 6s here. Those see those cells. This 6 sees that, so 6 is in one of these cells. Still no knight's move. Wow. Okay, well, there has to be a knight's move somewhere that I'm just not noticing. I'm gonna big brain this thing. I mean, this can't be a 9. Oh, okay. Well then this can't be a 9. Because a 9 here will remove 9 from these cells, which then makes there no 9 in this 2-4. Or this 24 cage, which it doesn't work. So 9 can't be in these cells, can't be in these cells. 9 can't be in this cell. It also can't be in this cell because the same thing would happen. So 9 must be there. Now these are 9s. So in each cell, these are 9s. Doesn't break yet, thank God. 7, 8 pair? How resolve? Wait a minute. That does not feel right. How do we resolve that 7? Oh, okay, probably knight's move. I hope knight's move resolves this. I hope knight's move will resolve this, because otherwise we are very stuck. It should. I trust that the puzzle is doable. 1 is in one of these cells. That removes a 1 from here, making there a 1 here. These cells are all fixed. So these cells are 2, 4, and 5. This can't be a 5. This can't be a 4. This one could be anything. Wow, okay. These cells are 1, 7, 8. This 1 sees that. This cell can't be 7, 8 because there's already a 7, 8 pair here, so that's a 1. Okay, that is an 8, that is a 1, that is a 7, which does in fact disambiguate this. This 7 sees that, so that's an 8, that's a 7. That's an 8, that's a 7. This 7 sees that, so that is an 8, that's a 7. This 7 sees that, so that is a 5, that's a 7. These are 6 and 5, 5, 6. 5 disambiguates that. 6 here, 5 here. This is a 4. That's a 6. This 5 puts a 2 here, 5 here. This 2 puts a 4 here, 2 there. This is a 4. These 2 cells are 2 and 8, which is resolved by this. 2 here, 8 here. These 2 must sum to 6 by zipper line rules. That's a 2. That's a 4. That's a 2. That's a 4. Oh, solved. Whew. Yay.